Hello everyone. So the topic that we are going to tackle this day is all about the antiderivative of exponential and logarithmic function. Okay, so we are now in quarter 4, module 2, lesson 1. Okay, so we have here for the antiderivatives of exponential and logarithmic functions. We have here the learning competency. Compute the antiderivative of polynomial, radical, exponential, and trigonometric functions. The objective: compute the antiderivative of exponential and logarithmic function. We have here the concept notes. Theorems on integrals yielding the exponential and logarithmic functions. Number 1, the integral of e to the power of x dx is equal to e to the power of x plus c. Number 2, we have integral of a to the power of x dx is equal to a to the power of x over ln of a plus c, where a is greater than 0 with a is not equal to 1. Number 3, the integral of x to the power of negative 1 dx is equal to the integral of 1 over x dx, which is equal to the ln of absolute value of x plus c. We have here an example. Determine the integrals of the following. Number 1, the integral of e to the power of x plus 2 to the power of x dx. Okay, so this is the combination of 1 and 2, where 1 is the integral of e to the power of x, and number 2, which is integral of a to the power of x, where a is the constant. Okay, so we have here the solution. From the integral of e to the power of x plus 2 to the power of x dx is equal to the integral of e to the power of x dx plus the integral of 2 to the power of x dx. And remember from the theorem number 1 that the value of integral of e to the power of x dx is equal to e to the power of x plus the integral of 2 to the power of x dx is 2x over ln of 2 plus c. Okay, so that is now the answer for number 1, which is the integral of e to the power of x plus 2 to the power of x dx. Example number 2, we have the integral of 3 to the power of x dx. This is theorem number 2, which is the integral of a to the power of x dx. Okay, we have here the solution. The integral of 3 to the power of x dx is equal to the 3 to the power of x over ln of 3 plus c. Okay, that is now the answer. We have here another example, number 3, the integral of 3 to the power of x plus 1 dx. We have here the solution. The integral of 3 to the power of x plus 1 dx is equal to the integral of 3 to the power of x times 3 to the power of 1. Remember that when we are going to multiply the same variable, we are going to copy the variable or copy the base, then add the exponent. That's why the result is 3 to the power of x plus 1. When we are going to separate that 1, this is integral of 3 to the power of x times 3 to the power of 1 dx. Okay, applying the theorem number 2, we have the integral of a to the power of x. So the result now is 3, the integral of 3 to the power of x dx, and the value of the integral of 3 to the power of x dx is 3 times 3 to the power of x over ln of 3 plus c. Okay, that is now the value of the integral of 3 to the power of x plus 1 dx. Okay, another example, number 4, the integral of 2 over x dx. And remember that 2 is in the numerator, so when we are going to separate it 1, it becomes 2, the integral of 1 over x dx. Okay, so when we are going to find the integral of 2, the integral of 1 over x dx, so the result is 2 ln of x plus c. Okay, so we have here the number 5, the integral of e to the power of 2x dx. Okay, this is the theorem number 1, where the coefficient of x is 2. So we have here the solution. From the integral of e to the power of 2x dx is equal to e to the power of 2x over 2 plus c. Remember that the integral of e to the power of x dx is equal to e to the power of x plus c. And remember that the coefficient of x is 1, so therefore the denominator of e is 1. That's why the result is e to the power of x dx. Since the exponent of x or the exponent of e is 2x, so therefore the denominator of e is 2. Okay, so the value now of the integral of e to the power of x dx is e to the power of x over 2 plus c. In example number 6, we have here the integral of 3e to the power of x minus 2x plus 1 over x squared dx. Okay, so we have here the solution from the integral of 3e to the power of x minus 2x plus 1 over x squared dx. When we are going to separate that one, it becomes the integral of 3e to the power of x minus 2x over x squared. So we can cancel x, so the result is negative 2 over x minus negative multiplied by positive, the result is negative 1 over x squared. The result is, when we are going to change that one, the exponent is negative, that is negative x raised to the power of negative 2, since 1 over x squared. So we have here the integral of 3e to the power of x minus 2 over x minus x raised to the power of negative 2 dx. Okay, so since 3 is a constant, so we are going to separate that one. It becomes 3 the integral of e to the power of x minus 2 the integral of 1 over x dx minus the integral of x raised to the power of negative 2 dx. Okay, so we have here from 3 the integral of e to the power of x, the result is 3e to the power of x minus 2 the integral of 1 over x dx is ln of x minus the integral of x raised to the power of negative 2 dx is x to the power of negative 1 plus c. Because x raised to the power of negative 2 plus 1, the result is x raised to the power of negative 1. Okay, so therefore, the value now is 3e to the power of x minus 2 ln of x plus x raised to the power of negative 1. When we are going to change that 1 into the x positive form, it becomes 1 over x plus c. So that is not the answer of the integral of 3e to the power of x minus 2x plus 1 over x squared dx. Okay, so what's more? We have here, we are going to evaluate the following antiderivatives. Number 1, the integral of 9 over 7x dx. Number 2, we have the integral of 4e to the power of x dx. Number 3, the integral of 2 to the power of x plus 4 dx. And number 4, the integral of 2e to the power of x minus 1 over 8x squared dx. You are going to solve that one. Okay, that is your exercises. Thank you for listening, and do not forget to click the bell icon to subscribe my channel.